Good day and welcome back to our discussion video on limits and continuity of functions of several variables. We are in part 3 now of our discussion where we want to check continuity of these three functions on your screens. So we will be recalling the conditions for continuity or for classification as removable discontinuity or essential discontinuity. Okay. Game. Let's do number 8. I just shortened the instructions into that sentence. I hope it captures the essence of what we're doing. Let's discuss the continuity of this piecewise function, which takes the form sine of xy all over x squared plus y squared for inputs other than 0, 0. Now, f of 0, 0 is 0. Okay. Let's check. First, we need to check if 0, 0 is in your domain and that it gives off a real number. Well, here it does, no? 0, 0 has function value 0. So that's the first condition. Next, we want to check if the limit exists. And hopefully it is 0 para mag-match doon sa f of 0, 0 so that we have continuity. Pero, may kailangan na tayong i-check dito kasi it turns out hindi na mag-e-exist yung limit. Okay, let's see. Let's prove that claim. No? First, well, since we're trying to prove that a limit does not exist, we need two curves through 0, 0. Okay? Let's take for our first curve maybe this one, x equals 0. And for the second one, we get y equals x maybe. No? Let's see if they work. For the limit along C1 of f of xy, we get the limit of the expression sine of xy over x squared plus y squared along x equals 0. So it will be reduced to a limit as y goes to 0 of the expression where all values or instances of x are replaced by 0. And sinimplify na natin. Well, sine of 0 is 0, so it's just 0. So the limit along C1 is 0. Okay, remember that, no? Let's now check the limit of f along C2, y equals x. Ito siya. If we take the limit along y equals x of this fraction, then we can replace the y's by x and take the limit as x goes to 0 of this one. If we take out a 1/2 from this expression, we get the limit of sine of x squared over x squared, which should remind you of some limit from Math 21. Ang layo, no? Or if you don't recall it anymore, you can always use L'Hopital's since it's 0 over 0 at this stage, no? But anyway, well, yeah, at least 2 iterations of your L'Hopital's rule will give the limit of 1/2, which is not 0, which is what we want, no? So na-prove na natin yung claim that the limit does not exist. Ouch, no? Ouch question mark. Kasi at this stage, we are now sure that the function is not continuous at 0, 0. And furthermore, since you have this non-existent limit at 0, 0, then we could actually go further and say that f has an essential discontinuity at 0, 0. Kasi walang limit. No? All right, so that is exercise 8. Let's now go and check the continuity for g of xy given in item 9. O, ito iba naman. 0, 1 naman for a change. No? Okay. We want to check continuity here. Okay. Once again, we check that g of 0, 1 is 0 from the second line. So there you go. Next, we check for the limit of g as xy goes to 0, 1. But this spoiler right here, well, if we put in there C1, so parang ano na, no? May feeling na tayo na baka non-existent to. Let's just verify that claim, ano? So, dapat may nakalagay dito na claim that the limit does not exist. Okay? Anyway, if we take that curve, notice it's not y equals 0. It's y equals 1. Careful dun, ha? Hindi pa laging uubra si y equals 0. For y equals 1, we get this limit of x, l, and y over x squared plus y minus 1 quantity squared. We plug in y equals 1 and let x go to 0. So we have this. ln of 1 is 0 and y minus 1 is 0. Overall, the fraction will be just 0. Okay? 0. Okay. Now, let's take another curve passing through 0, 1. If you try x equals 0, spoiler na lang, if you try x equals 0, the limit is also 0. Okay? But again, that does not mean that the limit is 0. It might be a different value for a different curve. For example, if we take C2 here, y minus 1 equals x. Okay? So itong y minus 1 papalitan natin ng x, or equivalently, y equals x plus 1. No? If we do that replacement, again, you can verify that 0, 1 is in here. Okay? Then we have the limit along this C2 of this fraction. What we will do is, we will write the limit in terms of x. Okay? So we have y is x plus 1, and y minus 1 is x squared. Yan siya, no? So now let's simplify that a bit. Ayan siya. There's a factor of 1/2 coming from your denominator, no? May 2x squared kasi dyan. And then one of the x's will be cancelled. So we have ln of x plus 1 over x. Another guy of 0 over 0 form. Meep. Ting, ting, ting. Ayan ha. L'Hopital's po. We'll take the limit of derivative of ln x plus 1. That's 1 over x plus 1. Over 1 na lang, no? For x. And that limit is 1/2, which is not 0. Ooh. Once again, we encounter two curves giving two different limits. So the hopefully familiar conclusion follows now that the limit does not exist. And we can now classify your discontinuity. So ito at this point, wala na siyang continuity, ano? Yung G. Furthermore, we could say G has an essential discontinuity at 0, 1. Okay? So that's going to be your answer for exercise 9. All right. So far, wala pang continuous na function. Let's try this one. The last item for our discussion video. X squared over x squared plus y squared for inputs other than the origin. And for the origin, the value is 1. Yeah. Sige, before I show the solution, you can try some curves. For x equals 0, kunyari, magiging 0 yung limit. Pag y equals 0 ang kinuhanan nyo ng limit, magiging 0 din yan. Sa y equals x, 0 din yan. Sa y equals x squared, 0 din yan. Blah, blah, blah. So, let's generalize this, no? In particular, I will be showing first, again, let's remind ourselves, dapat may h of 0, 0. Yan muna, no? Before we check the limits. Dapat meron muna. H of 0, 0. Okay? Now, for the limits that we have been talking about, no? If we take the curve C1, maybe of that form, some real number times x to the n, where n is a positive integer, then we get this limit along y equals mx to the n. So again, we replace the y's here by mx to the n. So ito siya. And then of course, the limit is as x goes to 0. Okay? Pag sinimplify nyo itong fraction na to, with the m's and the n's and the x's and all that, we should get this one. Okay. Here, we have to note na ang n natin, ang starting value niya 1. No? So this 2n minus 2 is at least 0. So it's at least 1. It could be x squared, x to the 4, and so on. However, the numerator has power at least 2. No? Kasi 2n yan. The point is, the numerator has a higher degree than the denominator. So if you put in x equals 0 there, magiging 0 din yan. Okay? Again, the justification is because 2n is at least 2, so that 2n minus 2 is at least 0. Okay? Actually, for this very same reason, this 2n greater than or equal to 2, ganun din yung mangyayari if we switch the spots or the places of x and y here. Kunyari, ganyan. For x equals my to the n, I'll just go through the steps here. This should be along C2, sorry. Here we replace the x's by my to the n. And using your algebra skills, this limit as y goes to 0, it will also be 0. Okay, this is interesting. Remember, this is not just two curves, two individual curves. These are two families of curves. E pag family of curves, di ba, infinite yun. Maraming pwedeng curve yun. So, our observation so far is that for an infinite number of curves, we have that limit. It must be 0. It might be 0. Might. Di pa natin alam. We have to somehow show that for any other curve, for example, imbento tayo ha, pwede siguro y equals ln of x plus 1. Pwede yun, di ba? Nandun ang 0, 0. Dapat, kahit pati doon sa curve na yon, ang limit 0. Pero, di ba, nakakapagod na maghanap ng limit, no? So, let's try something else. Maybe this one. Yeah! Yes, ladies and gentlemen, we will be concluding this discussion by an application of the epsilon delta definition. Okay? Let's go. I-recall natin paano yung definition na yun, no? So, again, ang target natin is that the limit is 0. Ito siya. Let's prove that limit by starting with taking some positive epsilon. Okay? This epsilon represents the distance between h of xy and the target limit of 0. Okay? Our goal will be to find some delta in terms of epsilon. Okay? So that the rest of this proof holds. No? If we assume that the square root of x squared plus y squared, essentially, yung distance ni xy, point xy, kay 0, 0. Okay? So, yun yung distance. If that distance is smaller than delta, of course, it is at least 0, no? Kasi nga distance. So, if we make that assumption, then we want to see where we will be led by taking the distance between h and 0, which is this. Well, that absolute value is not really needed kasi puro squared naman yan. And now we have to make a bit of comparisons here. For example, this x squared guy, it will be less than or equal to x squared plus y squared. Well, you're adding a square to something. So, dapat lalaki talaga siya. Okay? By that same argument, this y squared here in red should be at least x squared plus y squared. And now we see lots of x squared plus y squared terms there. But two of them will go away, and we will be left with this. Now that guy is the square of the square root. Yeah? But hep, this square root by assumption is less than delta, which gives us that inequality now. So the whole thing is less than delta squared, which we want to be epsilon. Ayun. Okay. So final step, since your delta is positive, this will only work when your delta is positive, no? Assumption yan. Ito, delta greater than or equal to 0. Since that's your assumption, we can take square roots to express your delta in terms of epsilon. And that proves your claim. Since we found your epsilon expression for delta, then the limit is indeed 0. Okay. Ito na, finally. Ang limit ay 0 nga yung limit, pero yung function value naman ay 1. Wala rin. So we were not able to obtain a continuous function here. However, this discontinuity for h is actually removable naman. Buti na lang, because we can redefine this small h such that the input at 0, 0 is 0 para maging continuous yung function h. Okay? And that ends our discussion for topic 1.2 on limits and continuity of functions of several variables. Okay? If you have any other questions about the topics covered in this 3-part video, you may consult with your discussion teachers. Okay? So, thank you very much for viewing this 3-part video, and our next target or topic to be addressed is the concept of partial derivatives. Okay, because remember, you have two variables now, so we can differentiate with respect to one variable or the other. Okay? Yan. Lecture 1.3. Exciting yan. Okay. So kung wala na pong tanong na gusto niyo ilagay sa comment section o itatanong sa discussion teacher nyo, once again, thank you very much and have a nice day. And may you all stay safe.